Hey everyone, GraphDBA here again with another video, and this is a two-part follow-on to my earlier video on creating ASM disk groups with the Dell PowerMax storage array. In this video, I'm going to show you how to clone ASM disk groups using the PowerMax's storage snapshot technology. But first, the boring legal stuff. Now, once again, I'm not going to read the whole slide here. The salient point here is that I work with Dell Technologies. That said, my opinions are my own and do not necessarily represent Dell. Okay, good? All right, let's move on. Back in November 2021, I did a video on cloning an Oracle database using a Dell PowerStore and thin clones, and in that video I provided a fairly detailed description of how storage arrays like the PowerStore and the PowerMax use a technique called redirect on write to deliver almost instant copies of ASM disk groups, and those copies take up a minimal amount of real capacity. I'm not going to repeat the whole explanation here. If you're interested, please do go check out that video. The short version is that what the OS and ASM thinks is a sequential block device is in reality just metadata sitting in the PowerMax's controller's memories, and the blocks are in reality scattered across all of the flash drives of the PowerMax. When the PowerMax makes a snapshot of an ASM disk, all it is really doing is saving the locations of the current state of the blocks of the ASM disk. Then, as further changes are made, the PowerMax redirects those writes to new locations within the PowerMax so that the snapshot of the ASM disk can be maintained. All of this is 100% transparent to the database and to ASM. And what's more, all of this is supported by Oracle as per MOS Note 604.683.1. Oracle expects us to maintain write order consistency across all disks in the ASM disk groups, so we group all of the ASM disks of an ASM disk group into a single PowerMax storage group. If you're not clear on what a storage group is, I did a video on PowerMax basic concepts for Oracle DBAs that might help. Essentially, a storage group is a container for volumes in a similar way that an ASM disk group is a container for ASM disks. All ASM disks for a given disk group should be grouped into the same PowerMax storage group. A storage group may hold multiple ASM disk groups. A storage group can also contain other storage groups in a parent-child type relationship. In this example, we have two storage groups, Swing Data SG and Swing Redo SG, and they are both children of the Swing SG parent storage group. The PowerMax allows us to make a snapshot of our storage groups. In this example, I've named it Swing Snap 1. I could have elected to create two separate snapshots, one for each of the child storage groups. It depends on what you want to do. On some storage solutions, the snapshot itself can be directly mounted to a target host. PowerMax snapshots are more sophisticated and therefore a little more complex, so let me explain. To use my snapshot as a copy, I need link devices. Link devices are regular PowerMax volumes that match the source volumes in quantity and capacity. If I have 6 volumes in my source storage group, I will need 6 volumes of an equivalent or larger size as my link devices. When I link my snapshot to the link devices, those volumes assume the state of the source volumes at the time the snapshot was taken. I can then mount the link devices to a target host, rescan the SCSI bus, and the ASM disk should be visible. I am then free to make whatever changes I wish to my mounted copy. In this example, I have renamed the ASM disk groups to SnapData and SnapRedo. If I then relink my link devices to the same snapshot, they will revert to the state of the source volumes at the time the snapshot was created, undoing any changes I might have made to the copy I had mounted. After I have linked the snapshot to the link devices, I can, if I wish, terminate the snapshot. The link devices continue to exist, allowing me to continue to work on the clone of the database. I can also restore a snapshot, which will revert the source volumes to the state that they were in when the snapshot was taken. This can be a very powerful data protection tool, allowing you to undo any changes made after a snap was taken. Imagine a large patch fails to apply cleanly. You could simply undo everything and return your entire database to the starting point in a matter of seconds. So here I am in the Unisphere interface we use to control the PowerMax, and you can see that we have a parent storage group called Swing SG and two child storage groups called Swing Data, which has 6 volumes, and Swing Redo, which has 4. There's also a Swing FRA storage group, but I'm not going to snapshot that as there are no files I need in that ASM disk group. If I move to my database mount host, I can show you that currently there is no Swing Data or Swing Redo disk groups present, and there are no disks for them either. I am using ASM filter drivers for this demonstration, but everything we do here would work just as well with ASM lib or UDEV rules or even a file system like ext or XFS. Checking the /dev Oracle AFD disks directory, you can see the disks currently managed by ASM. Back to Unisphere, and I will select my swing data storage group. I am then going to click Protect and create a new snapshot using SnapVX, and I'll name my snapshot Swing Data Snap 1. If I wished, I could set an expiry date and time for my snapshot. I could also create a recurring schedule so that snaps are taken every few hours, for example, held for a day or so, and then automatically expired. But for now, I'll just create a single ad hoc snapshot. Going back to the storage group view, you can see that we now have one snapshot for swing data. And if we click that link, Unisphere will take us to a screen where we can link our snapshot to linked devices. I could link the snapshot to an existing storage group with existing volumes, but Unisphere also allows me to create a new target storage group on the fly, which is very handy. It suggests the name Swing Data LNK SG001, so we'll go with that. And when the new storage group is created, it also creates the 6 volumes I need, which here have the identifiers 1 Charlie 0 through 1 Charlie 5. Next, we need to provision our newly created target storage group, so we'll select Swing Data LNK SG001 and click Provision. Here we can select which host or host groups to provision to, so we'll select the host group for our 2-node Oracle RAC, Oracle RAC Metro. And next, the port group. Our admin has already set up a suitable port group, 304 Foxtrot Charlie. Unisphere suggests a new masking view name, and we're good with that. Clicking Run now, and the snapshot volumes are presented to our database host. I used a little video magic to skip over the part where I created and presented a snapshot of the Swing Redo storage group. Moving back to the database host, we'll rescan the SCSI bus using the sg3util script. And when that completes, we'll use the command powermt check dev equals all to tell PowerPath to look for new devices and bring them under management. As this is a 2-node rack, we had to repeat both of those steps on the second node of our cluster. Now, there's no guarantee that PowerPath on the second node will assign the same device aliases to the volumes as node 1, but since we're using ASM filter drivers which rely on labels, it actually doesn't matter. Switching to the Oracle user on node 1, we'll use the afd scan command to look for new disks. And now if we use afd lsdsk, we can see our 10 new volumes, 6 for swing data and 4 for swing redo. And again, we'll repeat those steps on node 2 of our rack cluster to make sure all nodes can see the newly presented ASM disks. Alright, we can see that we have all of the necessary disks on both nodes of the rack cluster. We could, if we wanted to, now mount swing data and swing redo, but we want to rename the disk groups so as to avoid any potential confusion. First then, we will change the disk labels on our disks using afd unlabel and afd label. We will execute the afd unlabel command with the -f flag against the first disk of the swing data disk group. And now we repeat that operation for all the other disks of the disk group. Now we can create new labels using the afd label command. We want to rename our swing data disk group to snap data, so we will relabel the first disk to snap data 0. I'll use the rename flag as this device was labeled previously. And next the remaining disks, snap data 1 through snap data 5. And with a little video magic, we'll rename the swing redo disks to snap redo. We use node 2 to execute those disk unlabel and label commands. If we now move to node 1 and rescan, we can then use the lsdsk command to see the new disk labels. Next, we can use the ASM rename DG command to change the name of the disk groups from swing data to snap data and from swing redo to snap redo. I've sped up this part of the video, but it really doesn't take that long. You might also notice that I haven't bothered doing a check first on the disks. In this scenario with a snapshot I have just created, it's somewhat redundant, but best practice would be to do the check anyway. Next, I will launch SQL Plus and mount the newly renamed snapdata disk group in restricted mode, and then execute the command alter disk group rename disks all. And I will repeat this step for the snap redo disk group. This renaming of the disks, strictly speaking, it isn't actually necessary, but it's still a good practice to get into, so I like to do it. Next, I'm going to enable my 2 new disk groups on the 2 nodes of my rack cluster. In this example, ASM tells me that the Snap Data Disk Group is already enabled on the cluster, and that's because this isn't the first time I have performed this operation. I really should disable the disk groups when I delete the snapshots. Now I can start the Snap Data Disk Group on nodes 1 and 2 of my rack cluster, and then I will enable and start the Snap Redo Disk Group on both nodes of the rack cluster. Lastly, I'll use the lsdg command to show that the two disk groups are online. What I didn't show here was how to launch the Swingbench database that is on these cloned disk groups. I did a video a while back called Mount and Open an Oracle Database Cloned Using a Dell PowerStore that shows the entire repurposing process, and the same steps would be applicable here. Alright, that's all we have time for today. Hope you found it helpful. If you did, maybe click like. If you found it really helpful, maybe even subscribe to the channel. And you're always welcome to come check out my frequently gruff but hopefully always helpful Oracle insights at my blog, graphdba.wordpress.com. Stop by sometime. We'd love to see you.